Hello everyone, this is your course instructor Khushwant Fatnani. Let us start off with the session once again. Last time we were understanding about standing waves and we were in the unit oscillations and waves. So let us restart and resume from there. So we had learned that there is this concept called standing waves, and we were reading what a standing wave is. Standing wave. So last time we had learned that standing waves are formed when two waves, right, which have same amplitude and same frequency, right, same amplitude and same frequency, they're traveling with the same speed also. Everything is same. See here, two waves have same amplitude, same frequency and same speed, right? Just that they're traveling towards each other. When they travel towards each other, two waves, okay? That is how a standing wave is formed. So see here how standing waves looks like this way. One wave, or I'll draw with another color each one of them so it will be even easier for you to understand, right? This is how one wave looks like. Let's say I'm drawing one wave with green in color, right? See, this is traveling towards right. There is one more wave. Correct. Let's say it's traveling from here. Okay. Now both of these waves will superimpose, right? And what all quantities are same in them? Amplitude, frequency, and velocity. Everything is same. They are just traveling towards each other. That is how standing waves are formed. So how will the standing wave look like? Something like this. Have a look. One, and then overlap it with another one. See, right? So this is how a standing when two standing waves superimpose, they look like. Okay. Now, class, we were seeing about the equation, right? How do we match the equation? So we said that standing waves are a type of interference phenomena, right? So we take y is equal to y1 plus y2, where y1 and y2 are displacements of the individual waves. Suppose y1 was giving displacement of any particle here, right? And y2 was giving the displacement of any particle in the second scenario, right? And y is the net displacement of a particle which has two waves coming together, right? So we'll have y is equal to a sine omega t, right? First one, I'll write with opposite signs. Why? Because it's traveling in the positive x direction. So if you'll recall, whenever a wave travels in positive x directions, omega t and kx have different signs. Right? Different sign. And just the opposite, when wave is traveling in the negative x direction, right? Then omega t and kx have same sign, right? So same sign. So here, this is first one. So we'll take this as y1, right? Second one is a sine omega t, right? Plus kx, correct? After this, we'll sum them up. So we were doing this calculation last time when the class ended. We were doing y1 plus y2 is equal to a sine omega t minus kx plus a sine omega t plus kx. Anukriti, am I right? We were here, Anukriti, right?
Yes, sir.
Okay, so we had learned one formula and we had revised it, that we have a formula called sine c plus sine d, which is given as 2 sine half sum, that is sine c plus d by 2 into cos c minus d by 2, correct? So let us continue with this. We'll apply this formula here. We'll take a common, right? We'll take a common. Then we have this as suppose c. This entire expression becomes d. So sine of, we have sine of c plus d by 2, that is omega t minus kx, right? Whole plus omega t plus kx, right? C plus d whole by 2. Similarly, into cos c minus d, that is omega t minus kx minus omega t minus kx whole by 2. So this gives me a, right? This kx and kx gets cancelled. I have a sine 2 omega t by 2, which is omega t, into cos of minus 2 kx by 2, that is,
Sir,
just a second, just a second. So this omega t and omega t gets cancelled. So I get a, instead we have here 2, right? So we'll add that 2 also. So we'll get 2a sine of omega t into cos of kx, and we also know, just a second, we also know that, why did I do this transition? Because we know that cos of minus theta is equal to cos of theta, right? We know this. By that relation we have got this expression. So therefore we get the final expression for a standing wave as 2a sine omega t cos kx. Class, just have a look at this equation. Y is equal to sine 2a sine omega t cos kx. So if you will try understanding, no, this value omega 2a, this is the amplitude of the standing wave, amplitude of the standing wave, very important, right? Amplitude of the standing wave. Yeah, somebody was saying something. Yes, tell me.
no, sir. I just wanted to say that you missed the two in the
Yeah.
equation.
Yes,
You added it.
yes. Yeah, thank you. Okay, now class, once you have written this down, please raise your hand so that we can move to the next question. Yes, once you have written this down, please let me know so that we can move to the next question. Yes,
Sir,
yes, tell me.
so what's the phase here in this equation?
So I'm telling, we'll talk about it. So this is basically a standing wave, right? You talk about phase when a wave is traveling. So try recalling this thing, phase, this thing, phase, has a relation between path difference and time difference, right? When will you have a time difference between 2 points? When two particles are traveling in some time from one place to another, correct? Correct.
Yes, sir.
So we also have path difference defined for two particles which are traveling from one point to another, correct?
Yes, sir.
Correct. So basically in standing waves, you have separate existence of path difference and time difference, right? So we'll talk about it. We'll talk about how do we find out path difference between two particles, how do we find out phase difference between two particles. In fact, I think I can recall that we have learned this equation. Just tell me if we have already. Have we?
Yes, sir.
Right? So let's say if I tell you that two particles in a standing wave, okay, take this as a question. We'll do that But first, please raise your hand, all of you, if you have done writing this entire page. Yes, we'll take that up now. Is rest of everything, whatever we have uh, written on the board, is clear to everyone? Are the calculations clear? If the calculations are clear, you can bring your hands down. Yes. We'll take up that question, Karuna. Yeah. Okay, great. So have a look. So we have, now we are reading a very beautiful concept, right? Let's say on a standing wave, you have a standing wave formed. Okay, in this pattern. First of all, let us study a little about standing waves much in detail, and then we'll take up some questions. So since you have asked, we'll take up one, then we'll do an in-depth study and then questions. Okay. So yeah, let's say we have 2 points. Okay. One is point A and the other is point B. Yeah. Tell me what is the phase difference between 2 points? Yes, Karun, tell me. Try it out. First of all, can you find out what's the phase difference between them? What is the path difference between them? Delta x. Can you find out delta x for them?
Yes, sir.
Yeah.
It's by 4.
Lambda by 4, right?
Lambda by
Lambda by
4.
4. Why? Because this entire length is lambda, right? Entire length is lambda, and 1/4 of it, that is this one, will give me lambda by 4, correct? This will give me lambda by 4, right? The path difference between A and B will be lambda by 4, correct? Now we have a relation which connects phase difference and path difference. Can you remind us, Karuna? Yes.
So is delta x.
Just a second. I think there is some disturbance at your end, Karuna, so that's why I had to mute you. No worries. So the relation is delta phi is equal to k times of delta x, right? Where we had written that k is equal to 2 pi by lambda, right? Instead of delta x, we need to substitute this value. So we'll have lambda by 4, correct? Lambda and lambda gets cancelled, 2 and 4 gives you 2. So you have pi by 2, right? So what does this mean? These two particles which are vibrating at a distance of lambda by 4 have a phase difference of lambda by 2. So Karuna, can you tell me if the concept is clear to you? If yes, just raise your hand. I'll know. No worries. Okay, great. Okay, right. So if there is anything else, maybe you can send this as a question on the chat box. I'll take it up. No issues, right? No issues at all. So class, let us move to the next one, right? So when I'm talking about standing waves, let us understand it with a better insight. So a standing wave is given as in this pattern. See here, we just saw, right? This is one wave. So whenever no, you have any question in standing waves, just draw the waves in this pattern, the way I'm showing you. Draw the waves in this pattern, one wave, and then superimpose it with another wave, right? So we have this as a standing wave. Now let us categorize different parts of it, right? These parts where displacement is 0. These parts where displacement is 0 are called as nodes. Are called as nodes. These parts are called as nodes. Whereas these ones where amplitude is maximum are called as antinodes. Are called as antinodes. So this one is also an antinode basically. Yeah, please note it down, class. correct? Now we will see the mediums in which standing waves are formed, different kind of mediums, okay? So we'll have them as three of them, right? There are three of different mediums that we'll study about. One is a string. It's a string which is taught at both ends. That means, let's say you take one end, this is one, you tie a string, right? And here is the second end. You bring a standing wave on this. Second is, let's say you have an organ pipe. Organ pipe is just a simple hollow cylinder, right? Where waves can be formed. Third one is a closed organ pipe. This is generally called an open organ pipe, right? If not given, it's open. Open means it's open at both ends. When I say a closed organ pipe, you know what? Some students misunderstand this. Closed organ pipe means it will be closed at both ends, but no. Closed means the organ pipe is closed at one end. Otherwise, it will no longer serve as a pipe, right? So in order for this device, this cylinder to serve as a pipe, at least one end should be open and the other end is closed. So a device, a cylinder in which one end is closed is called as a closed organ pipe, right? Whereas if both ends are open, it's called an open organ pipe. Please remember this class, okay? So there are three mediums: string, open organ pipe, and closed organ pipe, in which oscillation takes place. But in all of them, we have different expressions for speed. See why? Because here the oscillations or the vibrations will be happening in a solid, and for a solid we have read V is equal to under root of, in a string we have read it's equal to under root of T by mu, where T is the tension in the string. T is the tension in the string. And what is mu? Mu is linear mass density. Mu is linear mass density, right? Whereas here in the organ pipes, the oscillations or the vibrations are taking place in the air column, whereas here it was a string. Whereas in the two cases, 2 and 3, we have air column which is vibrating. So how do we write down the values of speed in air? We had learned an expression, try recalling. V is equal to under root of gamma RT by M. Right? This is the expression for speed in organ pipe and open organ pipe and closed organ pipe, right? Okay. Class, once you are done with this, writing with this page, please raise your hand. Yes. Okay, great. Right. So let's move to the next part. Thank you, class, for raising your hands. You can bring them down. So we'll have the next part. We'll one by one see what type of vibrations can form, right? So class, let's say I have a string here. Yeah. Let's say this is string, okay? Now there are two terms, class, right? These terms are to pluck, right? To pluck or to touch. generally in questions, two words are used, to pluck and to touch. So when I say pluck, P-L-U-C-K, right? Pluck means you took your fingers, right, and allowed this part to come here. This is called plucking, right? So plucking will plucking at the centermost point will create a standing wave of this sort. How? Because when you pluck this, one wave goes here, right, gets reflected, and thereby another wave comes from this side. Similarly, one wave goes this side, another wave gets reflected from this medium and comes this side. So that is how standing waves are formed, and in a pattern that their antinode will be at the center. Antinode is at the center, right? So this is how we have first fundamental mode or first harmonic formed for a string, if we pluck at the center. So we are plugged at center, and what is formed is fundamental mode or first harmonic in case of a string. So we are seeing different cases in a string. Okay, this is called fundamental mode. Of vibration, or it's also called first harmonic. What is its meaning and how do we understand harmonics? We'll just study that in a short while. Okay, please first take this down. This is fundamental mode or first harmonic, right? Now we have, see, this is the length, right? This entire length. Karuna, can you tell me what this length is equal to in terms of lambda? Distance between two nodes is, two consecutive nodes is?
Lambda by 2.
Very good. So distance between two consecutive nodes. See, this is a node, right? And this one is another node. So the distance between them is lambda by 2. Absolutely correct. And in this case, this distance is equal to L, right? So we have L by 2 is, lambda by 2 is equal to L, correct?
Yes, sir.
Now, therefore, we can understand that in this particular scenario, we have, let's say if we have speed is equal to, or v is equal to lambda into f, right? Correct. Now, can I substitute instead of lambda v by f here?
Yes, sir.
If I do, see what is the expression that I get? I get L is equal to v by 2f, right? V by 2f. Or I can also write f is equal to 1 by 2 into v by L, right? 1 by 2 into v by L, right? So let's see one more understanding of it. What is the second pattern of wave which can form? So in case of string, no, you should remember a few things. In case of a string, take this as a note. At the ends, always nodes will be formed. Always nodes will be formed. Why? Because these nodes are the points of zero displacement. These nodes are the points of zero displacement. There is no displacement at this point. And of course, because here the medium is changing and we are entering into a complete different medium, that is, the wall is present here. That is why there is no displacement at this point. Right? So we have at ends always node is formed. Right? Now we'll therefore have another type of combination that can happen. See here. Now, no, class, always remember to make this diagram. As I told you, whenever standing wave questions comes, in somewhere in rough space, draw this diagram. Okay. This will make questions so easy for you, that you will be shocked that at one point of time you used to fear from this. It is so easy. See here. So first of all, draw it, right? Now, when two nodes, consecutive nodes were together, we use the first case, right? Now let us take second case. Start from one node, go till second node. Go till second node. Draw the diagram. Right? Will it looks like something like this, Karuna? Correct?
Yes, sir.
Now, Anukriti, tell me what will be the value of length now in terms of lambda?
It will be lambda only, sir.
Lambda only. Absolutely correct. Or what can I write it in terms of lambda by 2?
2 lambda by 2.
Absolutely correct. So this is the second case, right? Where L is equal to lambda, or I can write this as 2 lambda by 2, right? And on that note, we can write this as
2v by 2s.
2 times of V by 2L, right? Now class, try visualizing this, or try able to denote these two expressions. First frequency, right? First time the frequency was this F, or you call it as fundamental or first harmonic. This is the second harmonic. So this one, second one is called as second harmonic, or it's also called as first overtone. It's also called as second harmonic. Now I'm telling you very important point. Listen to it carefully. Okay. So whichever kind of instrument that we are considering, whether we are talking about string, open organ pipe, or closed organ pipe, always the first mode is always called as fundamental, right? Second mode is always called as first overtone. Third mode will always be called as second overtone, and so on and so forth. But if that is clear, keep also in mind, what does this harmonic mean? Right? So this is called as first harmonic. Now always the first one will be called as first harmonic. Second one, right, the next one need not necessarily be called as second harmonic. What does second mean? See here, we have 2 times of frequency here. In the second case is 2 times of the frequency in first case, and therefore this is called as second harmonic. Things will become clear when we write the next one. So we have, this was case of second harmonic or first overtone. Let us draw second overtone and see what kind of harmonic is that. Okay, again, 2 fixed ends, then in between them we'll draw. So we started with one first node, second node. Let's go till third node. Okay, so we have this, and finally this. Let me be more accurate. So we have okay, similarly second one also, and then we reach here somehow. Okay, let me be better. So I hope fair amount of justice this time. Okay, yeah, around, almost there, right? So yeah, so we have, see here, 1, 2, 3, and 4, right? Here initially we had 2 nodes. This was 1 and this was 2 in the first case. In the second case, we had 3 nodes, right? Now we have 4 nodes, okay? And we can clearly see that along with 4 nodes, we have 3 antinodes in this case, right? So this is case number 3. This is case number 3. And we will call this second overtone. Always first one is called as fundamental. Second one is called as first overtone. Third one is called as second overtone. Second overtone, right? Now, what about the harmonic? Let's try it out and get the answer. So here, Karuna, can you tell me what is length equal to? Length is equal to 3 times of?
Lambda by 2.
Very good. So which kind of harmonic should it be?
3.
Third
Third
harmonic.
harmonic.
Absolutely correct. Absolutely correct. So this should be third harmonic. Anukriti, is this point clear to you?
Yes, sir. It's clear.
Absolutely.
Yes, sir.
Right, this is how we'll define different kind of harmonics depending upon the frequency is how much times the frequency of the first or fundamental mode, right? So here we'll have f is equal to 3 times of lambda by v by 2l, right, where v by 2l was fundamental frequency. If suppose I denote this by f naught, so this is 3 times of f naught, right? So I hope the concept is clear to every one of you. So therefore we have in this pattern, for always remember this one is fundamental mode, first one. Second one was first overtone, right? And next one was second overtone, right? So this is how we have learnt about different modes, right? One by one for a string. This is called fundamental mode. This is first overtone. This is second overtone. So I request all of you to please jot this down in your copies, and once done, raise your hands, right? We'll wait for all of you. No worries. Yes. Once done, raise your hands. Yes. Yes, class. Once you are done, let me know. Okay. So, right, I hope every one of you is now clear with this concept that we have. You can bring your hands down. Thank you. So we have a string, right? And standing waves are formed in a string. If it's plugged at the center, right? Let's say, what about these two cases? Here we have plugged at a length of L by 4 from one end and 3L by 4 from another end. I'll show you how. See, what about this point? If this entire length is L, this entire length is L, this distance is L by 4, right? This part is 3L by 4. Am I correct? So we have this distance is until here. Until here, it's equal to L by 4. So suppose I pluck at a distance L by 4 from one end and 3L by 4 from another end. A point in such a manner on the string is plugged. Then which kind of harmonic will be produced in a string? Second harmonic. Are we clear? Here what happens? See here. Now this is L by 3 distance, correct? See here, if the entire length is L, we have divided this into 3 equal parts. So each one is L by 3. right? Suppose now I pluck at this distance, which is L by 6, which is L by 6, the center of L by 3, right? This distance is L by 6. So here we pluck at L by 6. If we pluck the string at L by 6, if we plug the string at L by 6, then it is it will undergo third harmonic vibrations, right? Atul, if you want to ask anything, you can ask. No worries. I think you got logged out in between. No issues. Do you have any queries with regard to whatever I've said until now? Otherwise, you can always go back and watch this again on YouTube. It will be uploaded on the channel Physics with Fatnani. So let me know, Atul, are you able to clearly understand whatever is written on the board? Yes. If there is anything to ask, please feel free. Yes.
Yes, sir. Fine, sir.
Is it clearly understandable at your end?
Yes, sir. At some point, till some point, sir, I can understand.
Okay, so I'll tell in brief whatever we have read, right, in last 5 minutes. So I have said that we started with the fact that we have different kinds of mediums in which vibration can take place, right? One is string, the other is organ pipe, and third is closed organ pipe. So we are considering the first case here, right? This first case is that of a string. So I said that if I pluck the string at the center, if I do, an antinode will be formed at the center. See here, we talked about nodes and antinodes, right? Were you there at that point? I hope yes, right? So antinodes were present. So here antinodes were formed. Now we considered fundamental, first overtone and second overtone. I told that irrespective of the type of device or the type of medium you're using, the first part will always be called as fundamental, second mode will always be called as first overtone, third mode will always be called as second overtone. Then I told that it is very easy to understand that in any standing wave, we have nodes and antinodes, and it's clearly understood using diagram that distance between any two consecutive nodes, so we'll write this here, distance between two consecutive nodes, between two consecutive nodes as well as antinodes is lambda by 2, right? Same thing. Please take this as note, between two antinodes is lambda by 2. Please take this notes, class. Take these key notes, right? So it's clearly visible here. This is lambda by 2. And similarly, distance between two consecutive antinodes is also lambda by 2, right? And if we talk about a node and an antinode, see here, if I talk about one node and next antinode, the distance is lambda by 4. Please take this also. Distance between adjacent node and antinode node and antinode is given as lambda by. Please take this down, class. Written. Once yes, you may raise your hands. Yes, class. Okay. All right. Okay, great. You can bring your hands down, class, right? So this is how we understood that we have here first fundamental mode being formed here, first overtone is formed, always the next one is called as I just told, second overtone. Now see here, why is it called second harmonic? Because see here, we wrote the expression L is equal to lambda by 2. We have lambda is V by F, right? So just here we have L is equal to V by 2F, and frequency given as frequency of vibration is given as V by 2L. Here frequency is 2 times of V by 2L, and therefore it's called second harmonic. Here in third case, frequency is 3 times of V by 2L. Therefore it is called as third harmonic, right? Third harmonic. So that is the reason of calling it second or first. So second harmonic means 2 times of the fundamental frequency. Third harmonic means 3 times of the fundamental frequency. I hope it's very legit and clear now. Let us take next one. Next one is the case of, next one is also class, if here you are to substitute value of V, what will you write? Atul, do you remember the value of V for a string? Yes, tell me.
Under root
Tension by
yes, a tension by
mu.
pressure, tension by
By
pressure.
mu. Under
Mu,
root
mu, mu, mu.
by mu. Where mu is
Mass per unit,
length.
mass per unit.
Right.
Yes,
Why?
sir.
Because here the wave is traveling in a string. And in a string, we had learned that velocity is given by under root of T by mu. Are we clear with this, Atul?
Yes, sir.
Okay. Great. So now let us take next question. So suppose we have next question given as, or next type of questions will be from the concept of organ pipe. So let's take the case of an open organ pipe. Next case, case 2. This was case 1. This was case 1. Case of a string, right? Here we learned about a string. Next one, let us learn about an open organ pipe. Right? So an open organ pipe will look something like this. Okay. So we have in an open organ pipe, again, how will you draw? See here, remember some rules. So one rule that we had learned, that in case of a string, at the end, always node is formed, right? Whereas you can learn basically a basic rule that whenever, I'll write this here, whenever end is closed, there will be no displacement, or y will be 0, and therefore at that end where there is no displacement, what should be formed? Node is formed. Whereas whenever the end is open and free to vibrate, at that end y will become maximum, and that point will be called as antinode. Antinode is, I hope it's clear for everyone, right? So please take this down. Please take this down, class. Now let's see about an open organ pipe. See here, this is also open end, this is also open end. What should be formed here, Atul?
At open end, antinode should be formed.
Absolutely. So the trick is, first draw with yourself a wave. Draw with yourself a standing wave. A standard standing wave that you know about. This is one part of it. This is next part. Correct? Now, this is first antinode, right? And this is second antinode. Let's draw this case first. This is between this part and this part. This is what we are drawing. Okay. So we'll have here, have a look, first case or fundamental mode for an open organ file will look something like this. To draw it better, right? Now see here at 2 points, the entering and the leaving point. At both points, we have displacement is maximum and antinodes are formed. Yes. So Anukriti, what's the distance between two consecutive antinodes we just read? Right? It is equal to
Lambda
lambda
by
by 2. Absolutely. So here we have L is equal to lambda by 2. Same substitution. We have lambda is given as V into F. We have V by F. So we have speed V is equal to V, V is equal to lambda into F, right? And therefore F is equal to V by lambda, right? So here, yeah. So here instead of lambda, I can write V by F. And we also have lambda is equal to V by F. So here we'll write V upon F, right? 2 will remain as such. Therefore, we'll have F is equal to V by 2F. This is case of first one, that is fundamental mode, right? Fundamental mode. So this is first case called as fundamental mode. First case will always be called as fundamental mode. Okay, first case will always be called as fundamental mode or first harmonic. Always, always, whatever kind of thing we are dealing with, whatever condition we are dealing with, right? Now let's take the second case. Very interesting. Now you all will tell me. Okay, so we now what should the diagram look like? How will I take the inspiration from this figure? Atul, try telling. We'll go from one antinode to first one we have got. Now we should choose. We should choose the third one.
Okay.
Correct?
Third, yes, sir.
Right. So we'll now have this zone. Class, have a look. This entire zone. Right. So how will it look like? Have a look here. Let's draw the pipe first. It will be very easy now, class. Very, very easy from now onwards. This entire concept. See, now we'll draw the modes. Okay. Second mode, we are drawing the first overtone, right? We are drawing the first overtone. Why? Because always the first one is called fundamental, second one is called first overtone. But which harmonic it is, you will realize when you find out frequency, right? So this is first overtone. Now, as Atul said, we'll take it up on one side like this, right? Second side like this. Am I correct, Atul? Something like this, correct?
Yes, sir.
Right? So this is so class. How did we choose this? It's very important to understand. We started from one end, this one, right? From one antinode, right? And we went to the second antinode. So this is how we'll keep on going, right? We'll keep on going. We can infinitely draw this standing wave pattern and choose to go from one antinode to second, then to third, then to fourth, right? And to fifth, and so on, right? So our entire concept or entire diagrams can be based on this one whole concept, right? Now, here, Anukriti, can you tell me what length is equal to this one? This distance is lambda by 4. This is
4.
lambda by 2, right? This is again lambda by
Lambda
4,
by 4.
right? So this entire distance becomes
Lambda.
or I can write this as 2 times of lambda by 2.
2.
Therefore, I have V is equal to 2 times of, or more importantly, let us write here we have F is equal to 2 times of V by 2L, correct? So
Yes,
this is,
sir.
so what kind of harmonic should it be?
Second harmonic.
Very good, very good. So we have this as second Harmonic. Karuna, can you tell me about the next one? How should we go how should we go about? We have taken this from first antinode to second, third. Now we should take now for which antinode? Yes,
Fourth antinode.
fourth antinode. Very good. So we'll take the organ 5, open at both ends. Just a second. So I'll clearly try to draw from this one. See how. So this is the third diagram which we are drawing. How will I draw? Let's say I forgot. I don't know, right? So I'll take this diagram. Right now, next one, correct? Let's start from this one. Let's start from here. This is second, this is third, this is fourth, right? So we have two mountains or two humps coming in between. So we have this as, we'll start from here. This is one, this is two, and then we end, right? So we have this as one, second hump, and then third. So class, this is how we have chosen to draw the second overtone. So I'll always write the third part as second overtone. I'll write this here, second overtone. Now, for the second overtone, we will have again, uh, tell me, Karuna, this is how much distance in length, how much is length in terms of lambda. So this is lambda by 4. This is lambda by
2.
2. This one is
Lambda by 2.
very good. This one is
Lambda by 4.
4. Add all of them up. What do you get? L is equal to,
Lambda. 6 lambda by 2.
or you can also write, uh, try thinking again, lambda by 2 plus lambda by 2 plus lambda by 2. That is 3 lambda by 2, right?
Yeah. 3
Sure. Or it's
Yes.
6 lambda by 2. Tell me. I may be wrong.
lambda by 2. 3 lambda by 2.
3 lambda by 2. Be very careful, right? Okay. So 3 lambda by 2, right? So we are definitely going to have what kind of expression here? We'll, instead of lambda, what can we substitute? Tell me from here. Lambda is equal to V by F.
F.
So we'll write L is equal to 3 times of 1 by 2 V by F. Let's exchange the positions of frequency and length. So I'll get
F is equal to.
F is equal to 3 times
3.
of V by 2L, correct?
Yes, sir.
Now V by 2L was the frequency of,
Fundamental mode.
the fundamental harmonic or first harmonic, right? Now, how much times the first harmonic is the frequency in this case?
3 times.
3 times. So what type of harmonic will I call it?
Third harmonic.
Very good. Concept clear, everyone? How to decide harmonics? If yes, and if you have written this down, please raise your hand. Yes, class. If you have written down this page, please raise this. Raise your hand. Yes. Okay, great. Now, class C here. Here we'll have the value of velocity given as for an air pipe. How much should be the velocity? Anukriti, V is equal to
Gamma RT by M.
very good. Gamma RT by M. Gamma
M.
RT by M. Absolutely. Absolutely. Now let's say I want to take the ratio of maybe frequencies, right? Will we be able to easily do it? In first case, frequencies were V by 2L, then frequency was 2V by 2L, right? Then it was 3V by 2L, right? So these were the ratios of frequencies. F1, right, is to F2, is to F3, and so on, right? So what does this ratio come out to be in case of a string? Yes, Atul, it is equal to 1 is to 2 is to
2 is to
3
3.
is to,
Yes,
and
sir.
so on, right?
4 so on.
Correct. So this
Yes,
is
sir.
the ratio of frequencies. Please take this down, class, in case of a string. In case of a string. What about the case of open organ pipe? Tell me. This one. Karuna, tell me. F1 is to F2 is to F3. Yeah,
So 1 is to 2 is to 3.
sure.
Yes, sir.
So what we have learned in case of an open organ pipe and in case of a string, right? In case of a string and in case of an open organ pipe, the ratio of frequencies are same, right? You can keep on continuing in this pattern. You can keep on continuing in this pattern, right? And let's say I ask you, what is the position of nodes in this case? Suddenly, I just ask you a random question. What is the position of nodes? Where all nodes are formed? Nodes are formed at C. Here,
At the center.
here at the center. I can call this as at a distance L by 2,
Yes, sir.
right? Now, what was L equal to here?
Lambda.
By lambda by 2,
Lambda by 2.
right? So I can call that this node is formed at the point lambda by 4 from here. This
Yes,
distance
sir.
is lambda by 4, right?
Yes, sir. Yes.
So node is formed at the distance lambda by 4. What about the second case? It's formed, first node is formed at the distance lambda by 4, right? What about the second node, Karuna?
3 lambda by 2.
Absolutely. Here x is equal to 3 lambda by 4. Here, tell me, where is the first node formed?
Lambda by 4.
Lambda by 4. When is the
3
second node
lambda
formed?
by 4.
3 lambda by 4. Where is the third node formed? 5
5
lambda by 4,
lambda by
right?
4.
So we have understood that nodes in case of open organ pipe are formed at a distance of nodes. Here nodes are formed at different lengths. That is, x is equal to lambda by 4, 3 lambda by 4, and 5 lambda by 4. You need not memorize all of this, but these are general quick facts that you understand just by seeing the entire term, right? Now tell me from here, at what points are antinode formed here in case of a string? Yeah, Anukriti, tell me. So this point is antinode. First antinode is formed at the distance x
Lambda by 4.
lambda by 4. What about second antinode?
3 lambda by 4.
3 lambda by 4, right? So are we all clear how nodes and antinodes exchange their position in case of a string and in case of a open organ pipe, right? So here, what about this? Atul, tell me. Here the first antinode is formed at a distance lambda x is equal
Lambda,
to lambda by 4,
lambda by 4. Yes,
4,
sir.
right? This one is lambda by
Uh,
3 lambda by 4.
okay, yes, sir.
See here. See, one node and one antinode. They are at a distance of lambda by 2. This is lambda by 2, right? And one antinode and node are at a distance of lambda by 4. Sum them up 1 by 2 and 1 by 4. How much you
Yes,
get?
3 lambda by 4.
right? 3 lambda by 4.
Yes, sir.
So this first case was until lambda by 4. The second antinode is at a distance of 3 lambda by
3
4
lambda by
is
4.
at 5 lambda by 4, right?
Yeah,
So here
5
we
lambda.
can write that in case of a string, the locations of antinodes. So what are these? These are location or positions of antinodes are lambda by 4, 3 lambda by 4, and 5 lambda by 4, right? What about nodes? What about nodes? Can you check them in case of a string? See here.
For
Let's see. First one. This first one is at x is equal to 0.
0. Yes, sir.
Right. What about the next one? It's at x is equal to lambda by 2.
Lambda by 2.
Right. This one is at
Lambda.
lambda. Very good. Very good. How about the next one?
3 lambda by 2.
Right. Or you can simply understand that here always they are formed at integral multiples of lambda by 2. So see here, it was 0 lambda by 2, 1 lambda by 2, 2 lambda by 2, 3 lambda by 2, and so on. Am I correct, Atul?
Yes, sir.
Right. So now let's see for the second one. Here we had node. Now let's see about antinodes. Okay. Anukriti, try telling me this first one. Here, antinode. First antinode is formed at
0.
x is equal to 0.
X is
Very
equal
good.
to 0.
What about the second antinode? This second antinode
Lambda by
is at
2.
lambda by 2. Very good. From where? We are talking about position from the starting point.
Start.
Position from the starting point.
Starting position.
Right. So this is lambda by 2. Now, how about the third antinode?
3 lambda by 2.
3 lambda by 2. How about the fourth antinode?
4 lambda by 2.
4 lambda by 2. You sure?
Yes, sir.
Try thinking again. Pakka. The entire length is 3 lambda by 2.
3 lambda by 2.
3 lambda by 2. Right. Think about it again. I'll wait for you. We have how many antinodes here, Anukriti? 1 in
4.
Yeah, right. This is 1, this is 2,
2.
this is 3, and this is 4. Now tell me their position. Yes, one by one. First one is at x is equal to 0, right? How about the second one? It is at
Lambda by
2, right? This
2.
distance is lambda by 2, correct? Now,
Yes, sir.
what about the next one? It is at 2 lambda by 2. Am I correct?
Yes, sir.
Right? So this one is at 2 lambda by 2. Another one from the initial point. This
Yeah,
last
that is
node
lambda
at
3
3
lambda
times
by
of lambda by 2. Now are you clear, Anukriti?
2. Yes, sir.
Pakka?
No, yes,
Okay.
sir.
So what have we understood, class? We have understood that in case of a string and in case of a open organ pipe, we have understood how to find out the locations of nodes and antinodes. Are we clear? Atul, are we clear with this?
Yes, sir.
Karuna, are we clear with this?
Yes, sir.
Anukriti, are we completely clear with this?
Yes, sir.
Okay, great, great. So, sometimes what I've written this here, ratios of frequencies, these are also called as ratios of overtones. Ratios of overtones. Once you have written this down, please raise your hand. You should write in your notes location of antinodes, nodes, right, and frequencies. Here, I've written it down here. Ratio of frequencies. Here also, location of node, antinode, and location of frequencies. Once written this down, please raise your hand. Yes, class. Okay, great. Now, right? Now let's come to the third case, case 3. You can bring your hands down, class. Thank you. So you have case 3. In third case, we are reading about a closed organ pipe. Is a closed organ pipe closed at both ends, Karuna?
No, sir. Open at one end and closed at one end.
Open at one end and closed at one end. A closed organ pipe. Several students do this error that they take both ends closed, right? But it's not in that pattern. It just means whenever I write closed, it means that it's closed at one end. Let's say this one. Okay. So it's closed at one end. Correct. Now we will have different kind of vibrations forming. Let's do it. So you can keep at any end you want, right? Let's say we are taking vibrations are coming from here, right? First one wave will come, right? It will get struck at this point, then a reflection will be produced for that wave, etc., and something will happen, right? So that is how a standing wave is formed in a closed organ pipe, right? Now, or any pipe which is not free to vibrate at the end. Remember, any pipe which is not free to vibrate at the end will act like a closed organ pipe. Remember this, okay? Remember this. So let's draw this quickly. Let's draw this quickly. So here, how to draw it? We have learned the trick. Now, next phase, next part of it. We have drawn a standing wave. Always at a closed end, what should be formed? Here, what should be formed? Atul, at a closed end,
Node should be formed.
node should be formed. Anukriti, what should be formed at an open end?
Antinode.
Very good, very good. So, how can we go from one antinode to another node in this diagram? Tell me, Karuna, is this the right pattern of choosing one antinode and one node which are closest to each other? Am I correct, Karuna?
Yes, sir.
Let's do it. So here you will have a diagram of this. Right? Something like this.
Yes, sir.
So we'll have, I'll draw it again. This is how the structure will look like. Now tell me, Atul, what is length equal to in terms of lambda? What is this length distance between one antinode and node?
4.
Lambda by
4.
4. So this L is lambda by
4.
4. Now we have relation between V, F and lambda is V is equal to lambda into F, right? Let's write down from here that lambda is equal to V by F. So we have 1 by 4 times V by F, right?
Yes.
Okay. So we'll write this as 1 by 4 times V by F is L. Let's exchange the positions of F and L. So we'll have F is equal to 1 by 4L. Am I right?
Yes, sir.
Okay. What will I call this? This will be called as
Fundamental.
fundamental or first harmonic.
Yes, sir.
Fundamental mode. Fundamental mode or first harmonic. Now let's take the second case in the same. Same thing, draw one pipe and close it at one end. Okay, cool. Let's close this at one end. Closed. Now, ding, 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 ding. Okay, now, Anukriti, tell me, what's the next closest distance between one node and one antinode? This one is an antinode. We'll start from antinode at this point. This will be antinode. While here we have to keep a node. Okay. So what's the next possible frame? We'll start from this point. Let's say I'm naming them A. This is B. This is C. This is D. This is E. This is F. Yeah. And this is G. Till which point should I go if I start from A?
Till D,
Next
sir.
possible combination. Yeah. Tell me.
D. A to D.
A to D. Very good. Why? Because here this is the second most closest combination possible between an antinode and a node. I will repeat. This is the second most easy combination or closest combination possible between an antinode and a node. Whereas the first one was here. This first closest was this one between A to B. Now it is between A to D. Correct? So we will write it in this pattern. Let's draw this. Here we have okay. Okay. Right. Now, Atul, try and tell me what is length equal to in this case. Yes.
So the lambda by 4 plus lambda by 2, that is 3 lambda by 4.
Absolutely. Is everybody else clear what Atul just told? This distance is lambda by. So we have two distances in this case, right? This one and this one, right? So we'll sum them up, right? We know that distance between one antinode and one node we just learned is lambda by 4. Between two nodes, it is lambda by 2, right? So therefore, we have total length is equal to 3 lambda by 4, sum of the two. Substitute again instead of lambda v by f. So you'll have this as 3 by 4 times of v by f. This implies that f is equal to 3 times of v by 4n. Okay. Right. So we have this, just a second, class. Yes. So we are studying about closed organ pipe and we have understood how to write down the fundamental mode and how to write down the first overtone. So this one will be called as first overtone. We have always learned the first one is called as fundamental, right? This was fundamental mode. First case is always fundamental. Second case is first overtone. Okay. Now, what kind of harmonic should we call this? Atul, tell me.
Third harmonic.
Why? Why third harmonic?
Because the multiple of v by 4 L is 3 in this case.
Because in this case, whatever we have got, see here, we have got the frequency as frequency for the first overtone. We can see that it is 3 times the frequency in fundamental mode or first harmonic. So when the frequency is 3 times the first harmonic, we will call this third harmonic. We'll call this third harmonic. Very important, right?
Yes.
See, so if I ask you a question, which of the harmonics will not exist in case of a closed organ pipe? I give you the option first, right, right, or fifth. Which harmonic will not exist? Second. Are you now clear?
Yes, sir.
Harmonic does not exist for a closed organ pipe. Right, for a closed organ pipe. So the answer will be second harmonic, as it's very clearly visible. After first, we have just got 3, right? By understanding. Are we clear with this, Atul?
Yes, sir.
Okay. Atul, are we clear with this?
Yes, sir.
Okay. We'll take the next one then. So what about the next one? How to draw the next one, Atul? Tell us, guide us. Yes.
So we will draw it from.
Let's draw. Just a second. So I will take once again a pipe here. First part of the pipe. This is second part of the cylindrical pipe. We will cover this with one end. We'll cover one end. Right. Now let's draw the wave. Okay. Now tell me from which point to which point should we go? If I want to go from one antinode, if I want to go from
We'll draw it from G.
one antinode.
We will draw it from G, sir.
Okay. One antinode to one node, right? So we'll go from in the figure. I have just written it down. Class, have a look. We are seeing this figure, right? So here, Atul, yeah, tell me. So we'll
Sir,
go from
point G.
point G. Are you sure?
Yes, sir.
If I start from one antinode, and I want to go to nearest node. Let's see one by one. See here. I want to start from antinode. So I'm starting from A. A is representing an antinode, right, in the figure.
Yes, sir.
So I'll tell you once again what I'm talking about. So here, have a look. This one. A is over here, okay? This is representing me the antinode. This is representing me the antinode. I want to start from this point. I want to start from A or the antinode. Why? Because an antinode will be formed at the open end. Now I've seen the cases where next other point should be of the node, right? So I can reach another node by going from A to B, right? What is the next closest distance? Will be A to D.
B.
A to D, right? Where is
Yes,
the
sir.
next? Where is the next antinode, Atul? It is until F, right? See here, it is at
Yes, sir.
F.
Hmm.
Are you able to understand? See here, I
Yes.
want to go from one antinode to another node. So the shortest way is by going from A to B. Next shortest way is going from A to D. Then next shortest way is going from A to F. See, because at F a node is there. I want to go from an antinode to a node, and I'm searching for the shortest path possible. Correct? Are we able to understand this, Atul?
Yes. Yes, sir.
Okay, so this will be the another third shortest path.
So
Let's,
we are all, we are always starting from A point only.
why? Tell me, because here an antinode has to be given.
Okay. Okay. Yes, sir.
Because here at the open end, we have to draw an antinode. So I'm seeing that what are the ways of reaching from one antinode to another node? Because here at the closed end, always a node is formed, right? So I want to go from, see here, Atul, first diagram, I had to go from an antinode to a node, right? Here also, I had to go from an antinode to a node. But every case, I'm thinking that what are the ways in which I can reach from an antinode to a node? So here I reach just by taking a distance of lambda by 4. But for the next one, I had to take a distance of 3 lambda by 4 in order to reach from one antinode to the next node, right? Another one is this one, correct? See this one. This is how also we are reaching from one antinode to a node over here. Antinode to node. First way is from A to B. Second way is from A to D. Third way is from A to F. Are we clear? Antinode to node.
Yes, sir.
Okay.
And so
Yeah.
sir, in previous cases also we took it from the initial position only, the whole
Why?
length.
Why did we do that? Because see
It
here.
was starting from antinode.
Because we wanted to start from an antinode. So in this case, or the case of the open organ pipe, see, we drew this. So we started from an antinode. Why? Because here also an antinode is there, and the next end also antinode is there. So we'll see what are the ways of reaching from one antinode to another antinode. So if this is the starting point, first one, if this is the starting point, this one is the starting point. So I know the way of reaching from one antinode to another antinode is, let's say I'll again name the points. Let's say this is A, right? This is B, this is C, this one is D, this one is E, and this one is F. Next one is G, right? So Atul, you only tell me, what are the ways of reaching from one antinode to another one? I'll start from
So the
A, I'll go to
C
I'll go to C. What's the next way to go from one antinode, that is A,
to
to
E,
another antinode? Is going to E,
E,
right? And then next way is going to
G.
G. Are we now clear, Atul?
Yes, sir.
What about the first case of a string? We had to go from a node to another node, correct? One
Yes, sir.
node to another node. So here, let's say we have same naming. Let's say this time we'll name this point. Initial point will be node. Why will I take node as the initial point this time? Because we want to start
Start.
from a node. We want to start from a node. Are we clear, Atul?
Yes, sir. Yes, sir.
So now we'll go to which point. Suppose I name these points as B, C, D, E, F, G, right? H. Yeah, tell me. So I want to
From
start
A
from
to
A first, go to next node. Where is the next node?
C.
C. Okay. Now I want to start from A and go to even further node, to a further node. How will I go it?
Uh,
Go A to E. Correct?
yes, sir.
Now I want to start from A and go to even further, to a further node. So A,
Uh, to
F,
G.
G. Sorry. Yeah.
Yes, sir.
A to G. Absolutely correct. Absolutely correct. Are we clear with this concept completely, Atul?
Yes, sir. Yes, sir.
Okay. So therefore, we'll go from, in this case, we'll go from A to which one? F, right?
Yes, sir. A to F.
In the first case, we have gone from A
A
to
to B.
B.
Yeah,
In
in the first case, A to B.
in the second case, we have gone from A to
A to D.
D. In the third case, we'll go from A
A
to
to
F.
F.
We'll do one thing. We'll write in others also. Here we went from A to C, right? In the second case, we went from A to E. In the third case, we went from A to G, right? Okay. What about here in this case, Atul? In the first one,
From A
using
to
this figure, using this figure as the, using this figure as the kind of reference, we are going from which point to which point in each of
A
them. Yeah.
to
So
C.
fundamental. Tell me.
A
Then
to
we are
C.
going from A to C, one node to another node. Okay, this figure. Now, what about the second figure? We are going from A to
A to E. E
E. Absolutely, absolutely. Okay. What about the third one? We are going from
to G.
A to G. Very good, Atul. Absolutely correct. Are you clear, Atul? It's very
Yes, sir.
important to be clear with this concept. Clear?
Yes, sir.
Okay. Now let us take antinodes and nodes in this case. So we'll have A to F. So there are two. This is, we're starting here. So I'll try to be more precise. Yeah, Atul, have a look. Are we correct in our drawing? In going from A to F.
Yes, sir.
Now tell me, what will length be in terms of lambda? This is lambda by 4.
Lambda by 4.
So we have,
Lambda plus lambda. 3 lambda by 4.
right, this is lambda by
5
4.
lambda by 4.
This
5
is
lambda by
lambda
4.
by 4. This one is lambda
Lambda
by
by
2. Right, this one is again lambda by 2. Right. So we
yes, sir.
have L is equal
5
to 5
lambda by
lambda
4.
by 4. Sum of all of them, right?
Yes, sir.
This can be written as 5 by 4 into B by F. Therefore, we'll have frequency is equal to 5 times of B by
B by L.
4L.
4L. Yes, sir.
So we will have, which harmonic is this?
Fifth harmonic.
Sorry?
Fifth harmonic.
Fifth harmonic. Very good. So this one is fifth harmonic. And which overtone? This is
second overtone,
second overtone, and this one is fifth.
fifth harmonic.
Very good, very good. Why fifth harmonic? Because this frequency is 5 times the frequency of fundamental. 5 times the frequency of fundamental. Therefore, it is called as fifth harmonic. Therefore, it is called as fifth harmonic. Right?
Yes, sir.
Are we very clear with this concept?
Yes, sir.
Pakka?
Yes, sir.
Okay. Have you written it down?
No, sir. The third case.
Yeah. Please write it down. Yes.
Yes, sir. Written, sir.
Done?
Yes, sir.
Okay, great. So now let's do one thing. We will try to write the same three things. Which three things we had learned last time? Positions of nodes, antinodes, and the ratio of overtones, right? Tell the same three things in this case also. So position of, let me write it over here in this part. Yeah. So I'll maybe write this properly. This is fundamental or first. Fundamental mode or first. Now I'm writing the same three things. Tell me. Yes, Atul. So what about the location of nodes in this case? Location of nodes. Yes, tell me.
So x equals to 0. First node is at x equals to
Here,
0.
here. Yeah. Tell me.
First node it has is at x equals to lambda by 2.
Lambda by 2. Sure? Are you sure?
Yes, sir. Yes, sir. Yes, sir.
See, actually, Atul, in this case, what we can do is you can either consider it from one side or other side. Let's say I'll draw this diagram again to avoid any confusion. See here. I'm drawing a closed organ pipe, this time in a way that you'll get node from a closed end. Node from a closed end. Let's see, let us make closed end initially here. This is first diagram. This is second diagram. Right, now let us draw the vibrations or modes. So first one was this, right? Fundamental, correct? What about the second one?
Um, First harmonic, second, third harmonic, first overtone.
Now what about the next one? We have right now, just a minute. Okay, yeah. So the third one was fifth harmonic. So we drew it as okay. Now tell me here in the first case, this was f is equal to
V
Yeah,
by
tell me.
4n.
V by 4n.
4n.
Here, F is equal to
3V by 4n.
3V by 4n. Okay, here F is equal to
5V by 4n.
5V by 4. Now I think it will be easier for us to mark these three things, the locations of nodes, antinodes, and the ratio of overtones. So let's first write, this is a case of closed organ pipe, right? Now we have first the fundamental one or the first harmonic. This is called as, I'll write their names also. Right? So this one is first harmonic. This is case of third harmonic. Right? And this is case of fifth harmonic. Right? Now we will have here, have a look and tell me location of nodes from the closed end. Node from closed end. Right? This is point x is equal to, tell me x
0.
is equal to 0. So first is at x is equal to 0. Tell me where is the next one?
Lambda by 2.
Lambda by 2. How about this is lambda by 2? What about this?
Lambda.
Lambda. Or I can call all this as also 2 times lambda by 2. Right? Next one should be at 3 lambda by 2.
2.
Are we clear with this, Atul?
Yes, sir.
Okay. What about the location of antinode this case? Antinode from the closed end. Here antinode from the closed end will be x is equal to first
Lambda by 4.
lambda by 4, or we'll see only this one, last one. I think this is sufficient now. This is at lambda by 4. Okay. What about the next antinode?
Uh, Lambda by 2.
Let's check. So I'll mark it with blue. Okay. So this was first antinode, right? This was next antinode. Be
Yes, sir.
very sure. Be very sure. Okay. So this one is, this distance is lambda by 4.
4.
This distance is lambda by 4.
4.
Distance is lambda by 4. Now tell me, location of second antinode is at
Lambda by 2 plus
3
3
lambda
lambda
by
by
4.
4.
Lambda by 4, lambda by 4, lambda by 4, 3 lambda by 4, right? So here the location is at 3 lambda by 4. What about the even further antinode?
5 lambda by 4.
Very good. This is 5 lambda by. Are you clear, Atul, what I'm talking about?
Yes. Yes, sir.
You know, we have to find out what is the position of antinodes from the closed end. From the closed end. So you had them as lambda by 4. First one, next one is at 3 lambda by 4. And even the further one is at 5 lambda by, right? So this came out to be as 5 lambda by 4. Okay, what about third one? That is ratio of overtones. Tell me.
Ratio of frequencies.
Yeah, or you can also call them as ratio of overtones.
Yes, sir. Overtone. Sir, 1:3 is to 5.
See, this was fundamental, right? This was fundamental. Actually, I think we have done one silly thing here. I want to remove one part. See, when I talk about ratio of frequencies, Atul, we can always write 1 here. We can always write 1 here, right? But when I just talk about overtones, then can you include the first one? Because the first overtone starts from second harmonic, right?
Yes, sir.
So here you then cannot include, when I talk about overtones, then you cannot talk about the fundamental mode. Are you clear, Atul?
Yes, sir. Yes, sir.
You know that whenever I'm talking about frequencies, then the first one will come, right? When I talk about ratio of frequencies, then the first one will come. But when I talk about just overtones, then we'll start from the second one. Why? Because first overtone is the next,
Fundamental.
right? Are you clear with it, Atul?
Yes. Yes, sir.
So here also, when I'm writing overtones, ratio of overtones, I will not bring 2 here. I will not bring 2 here. This will not be there. 1 here, sorry. I'll recorrect or I'll correct this part basically. Let us write it in both aspects. We'll write ratio of frequencies and ratio of overtones. In case of an open organ pipe, ratio of overtones, and in case of an open organ pipe, ratio of frequencies. So ratio of frequencies is, yes, Atul, tell.
In case of closed organ pipe or open organ.
In case of open organ pipe, the one which is there on the screen. Yeah.
Yes, sir. 1:2:3.
Is the ratio of frequencies, correct?
Yes, sir.
We can clearly see 1:2:3. But what about overtones? In overtones, we'll exclude the fundamental mode, correct?
Yes,
So
sir.
it should be 2:3:4:4, and
Four. Yes, sir.
are we clear, Atul?
Yes, sir.
Okay. Now, let us see these 4 aspects again for a closed organ pipe. Here we have ratio of overtones and ratio of frequencies. So ratio of overtones. How do we get ratio of overtones as? Yeah, tell me. 3 is
Uh,
to
3:5:7 is
so on, right?
yes, sir.
Correct? Okay, what about ratio of frequencies?
1:3:5:7.
Absolutely correct. Absolutely correct. Are we clear with this, Atul?
Yes,
Concept?
sir.
Very clear that whenever I'm talking about overtones, then I will ignore the first one or the fundamental mode, right? So I'll write for the convenience of everyone. This first harmonic was actually fundamental mode. Always, whenever we are talking about any kind of instrument, right, the first one will always be fundamental mode, instrument of vibration. Then this will be fundamental mode. Next one will always be, tell me, always be first, Atul. It will be called as first
First overtone.
overtone. What about the third one or the next one?
Second overtone.
Second overtone. It's very crucial to the understanding, right? Because you get questions from this, like, pretty good number of questions, right? Pretty good number of questions are asked from this concept, right? So this was all about it, right? In the evening class, let's study beats and Doppler effect and study the questions which I sent you all already, right? So we'll take up those questions, right, and do as much practice as we can, right? So Atul, we'll do a quick revision of what we have read. In case there is anything that you want to know, let me know, right? So we first understood the concept of a standing wave. All that we have done in today's class is the concept of standing wave. We have understood that in the equation of standing wave, we have sine into cos expression. Sine into cos expression. Correct? Am I correct, Atul?
Yes, sir. Yes, sir.
Okay. Atul, there is one more fact. I don't know if you're able to find this out. See here that I can write the equation of a standing wave as 2a cos kx into sine omega t. Sine omega t. Suppose I fix the value of a. Suppose I fix the value of x. Sorry. Just here we learned, right, different values of nodes and antinodes. Just now we learned different values of nodes and antinodes. Correct?
Yes, sir.
Suppose I tell you that give me the displacement, vertical displacement at x is equal to some value, let's say 3 lambda by 4 or lambda by 4. Will you be able to give that?
Yes, yes, sir.
Of course, y is equal to
2a
2a.
sine omega t cos kx.
See, cos kx into
Sine omega t.
sine omega t. Now I tell me what is the amplitude. tell me what is the amplitude for x is equal to lambda by 4. What will be your answer?
Uh,
2a
2a cos k into
2 pi by 2 pi by lambda into
2 pi by lambda into
lambda by 4.
lambda by 4.
Correct. This will be the amplitude of a particle which is vibrating at the position x is equal to lambda by 4. Are we clear, Atul?
So then why we are taking cos kx as also the amplitude, sir?
Because we are talking about that particular value. So I'll actually clarify this. Let's take this up in evening class, right, with other students also. So Atul, please remind me, right? Please remind me as we begin the next class that, sir, we'll solve some questions on the basis of, or I'll give you such questions the assignment. Don't worry, right?
Yes.
I'll give you such questions the assignment. Okay. So, okay. Let's revise. Let's continue revising only. It's a very good concept because you get questions on this in exam. So we have standing wave, right? First part, it's written in terms of sine and cos, right? Then we learnt about standing waves in general. We understood that how do you find out phase difference between 2 points where path difference is given, right? Then we understood the concept of string, open organ pipe and closed organ pipe, taking this point into consideration that whenever the end is closed at that point, node is formed, whereas whenever the end is open to vibrate or free to vibrate, we have an antinode that is formed. Then we understood about a string, 3 cases: fundamental mode, first overtone, fundamental mode, first overtone, and second overtone. We also call these as, always the fundamental mode will be called as first harmonic. So we saw the first harmonic. Then I told that depending upon what's the frequency. So if the second next one for the first overtone, if the frequency is 2 times of the frequency in first harmonic, then you call this as second harmonic. Similarly, here frequency is 3 times. So you call this as third harmonic. This was the case of a string. Then you came to an open organ pipe. Here again, first one is always called as first harmonic or fundamental mode. Then next one is always called as first overtone, and the even next one is called as second overtone. Now we see that this one is first harmonic, right? And depending upon the, again, the frequency ratio. So here frequency was 2 times the first one. So we called it second harmonic. Here frequency was 3 times the first one, or V by 12, 3V by 12, right? So we called it third harmonic. Then we saw the ratio of overtones, ratio of frequencies, positions of nodes and antinodes in all the 3 cases, one by one, right? Okay. Then what next? Then we saw a closed organ pipe. So in a closed organ pipe also, first one is always called as first overtone. Okay, I think, pardon me, I think I've written this as first overtone. This is just fundamental mode or first harmonic. Yeah, so this is fundamental mode or first harmonic. Next one will be called as second overtone and third overtone respectively. And why are we calling it third harmonic? First overtone is called as third harmonic because here frequency is 3 times the first one. Here frequency is 5 times the first one. So it's called fifth harmonic, right? Then we understood in brief that how do we write down locations of nodes, antinodes, ratio of overtones and ratio of frequencies. Are we clear?
Yes, sir.
Are we clear completely?
Yes, sir.
Okay. Okay, then let's catch up in the evening. I'll send you some assignment questions. Solve them up, right? Try solving them and let me know if you have any queries. And of course, we'll be discussing them, all of them in the evening class, right?
Yes, sir.
Okay. Thank you, Atul. Thank you for being a part of the class. Thanks a lot. Anything you want to ask, Atul? Any queries? Any doubts?
No, sir. No, sir.
Clear, right? Everything clear? Whatever we read in today's class?
Yes, sir.
Okay, great, Atul. Then let's catch up in the evening with the assignment questions and let's practice more number of questions on the concepts that we have read now. Okay, great. Thank you, Atul. Thanks a lot.